Hey guys, today I'm going to be talking about the skip list. It's an alternative for the over focusing on balance, and it's also very commonly used in industry. So I thought it'd be a good topic to, review for this week. So here's like a very basic two layers example that I want to introduce. So we just don't like over complex the problem. So at the beginning, we would only have the normal lane. As I pointed, it's like a sorted list, but that's not good enough because if we want to search through something, the time complexity is O(n). And that's why we add an express lane on the top of it to reduce the time complexity. And the way we choose it is just like we just evenly pick like some nodes from the normal lane, let's say like 10, 30, 57, and 67. And then I'm just gonna do like a very quick search, let's say for like 45. So we'll go on express line. It's bigger than 10, bigger than 30, not bigger than 57. So we go back to 30 and then we go down to a normal lane and we do 43 and then here's like 45. And that's how we find like a number in this order list. So we want to briefly study the time complexity for search with like two layers. Suppose like we put like X amounts of nodes. Like in this example, we did 4, but we can just put like any random amount of like nodes to the express lane. Then the time complexity would be the number of nodes on the express lane plus the number of nodes on every section in a normal lane. Let's say like between 30 and 57, like how many nodes we have to go through to like actually search for the target. And that'll be x plus n divided by x. And with some basic mathematics, we can know that the optimal division would be square root n, and the time complexity would be square root n plus n divides square root n. That's like 2 times square root n. But then the big O will still just be like square root n. So with the number of nodes in the express lane as like the extra space, we're able to reduce the time complexity to O square root n. Thank you, and that's all we have for this week.